Our topic today is CIRA microwave sounder products for tropical cyclone analysis and forecasting. Our presenters today, we have three presenters, Dr. Galina Chirokova, Dr. Mark DiMaria, and Dr. Shishin Ruwan. Our facilitator today is Jorel Torres, also from CIRA, Colorado State University. A few reminders before we get underway. This session is being recorded. Please see the pinned message in the chat for Privacy Act information. We'll take after the presentation as usual. Please post your questions in the chat. Use your full names when asking a question. And if you're interested in presenting, please fill out the form, the link for which we're going to drop in the chat in just a moment. And if you're interested in presenting, fill out that easy form. We're glad to have you present at a future seminar. And there's the form now. And also, if there's any other feedback you have on the SBC session, please feel free to take that survey. We've added a link there. And training assistance, please contact Ross Van Til for either locating, finding, or maybe proposing or assisting in development of training materials. Thanks as always to the OCLO, GEO and LEO programs for their support of the Satellite Book Club and related projects. Before we get underway, we'd like to introduce a few words about our three speakers. First, Dr. Chirokova is a research scientist at CIRA who develops tools to improve tropical cyclone analysis and forecasting. Her work uses satellite imagery, AI, and statistical models, and many of her tools are now used by the Weather Service's Hurricane Center. Dr. DiMaria is a senior research scientist at CIRA and an AMS fellow. He spent his career developing tools to help hurricane forecasters, many of which are used by the National Weather Service today. He's received multiple awards for his contributions to hurricane forecasting. And Dr. Ruwan is a postdoctoral fellow at CIRA, where she focuses on using machine learning and satellite data to improve tropical cyclone analysis and forecasting. She works on storm classification models and applications for satellite imagery. Before CIRA, she worked with optical and radar data for cryospheric research. We welcome all three to the Satellite Book Club. And who's ever presenting, feel free to take the mic. I wasn't sure who was going to be speaking first.
Yes, I will start, and then Mark and Shishin will present their part. Hi, everyone, and thanks for the opportunity to present at Satellite Book Club. And next slide, please. So the outline of our talk, we will discuss why we want to use LEO satellite data for TC analysis, and discuss available microwave sounder data and how we get from radiances measured by satellites to physical quantities. And then we will introduce our operational hurricane intensity and structure algorithm, and discuss several experimental algorithms, and finally introduce planet near real-time demonstrations and future plans. And next. Why we need the LEO data for TC analysis and forecasting. So tropical cyclones spend most of their lifetime in remote regions away from land. So if you want to track tropical cyclone through its life cycle, satellite data is pretty much your only option. And satellite data are routinely assimilated by numerical forecast models, but they can also provide model-independent TC diagnostic parameters, such as intensity, wind radius, storm structure, and that is what we're working on. Now, tropical cyclone forecasters widely use geostationary satellite data, which are available every 10 minutes at high spatial resolution. And the question is, why do you need LEO satellite data, which could be only available about twice per day per TC per satellite? And the reason, one, is that LEO satellite data are really truly global. You can see the tropical storms in Atlantic and West Pacific and Indian Ocean with exactly same satellite and same instrument, which is not true for geosatellites, which cover large area, but you need several of them to cover the whole globe. But more important, LEO satellite data carry instruments which, due to limitation of the orbit, cannot be placed on geo satellites. And I'm just going to point out a couple of them, such as VIRS day-night band, which helps TC forecasters to avoid sunrise surprise of a first visible image in the morning. And we also use it, VIRS DNB, to develop ProxyVis imagery, which mimics visible imagery at night. But what we're going to focus today is microwave sounders and imagers. Microwave sounders imagers are only available on LEO satellites, and they can see through clouds, something which you cannot achieve with visible and IR data available on geo satellites. And next slide. Previous one. Okay, so the available passive microwave sounders. AMSU available on METOP satellites, ATMS available on GPSS satellites, Tropics, NASA Tropics experimental mission, which both Mark and I are part of the science team for it. And finally, Tomorrow.io, which is a commercial project which has satellites very similar to Tropics. And next slide. So this is a pretty busy slide, and what it shows, I don't want you to go through all the details, but what I just wanted to show where do the CIRA LEO TC projects stand. So in the upper left corner, we start with channels, and I showed channels for ATMS and Tropics, and then weighting functions. And this could be used to get either raw brightness temperature. At the bottom, you can see the brightness temperature for Tropics as displayed in AWIPS2. And you can also get retrievals, which gives you temperature and moisture through the profiles. So all applications we're going to discuss today actually use as input this temperature and moisture retrievals. And in the purple, like large purple box, show what we develop as part of our several LEO TC projects, which include some GPSS projects, Tropics projects, and also some DAX projects. So as a first step, we start with this global MIRS retrievals. And when you work with LEO satellite data in tropical cyclones, you have a problem of two moving objects. Satellite is moving and tropical cyclone is moving. So as a first step, we need to collocate them and actually extract data around the tropical cyclone. And for that, we have ETC Terra, which is a collection of Python libraries, which hugely simplifies that and allow us to quickly apply our applications to new data and satellites. And so we start with getting that temperature and moisture, and then for TC analysis, in most cases, not always, but in many cases, the most convenient framework is to regrid data to cylindrical grid around TC center. And what you see in the middle on the right, there are two plots showing a vertical temperature profile and vertical profile of mixing ratio. And the vertical axis is pressure and horizontal axis is distance from TC center. And this vertical, storm-centric profiles on cylindrical grid is basically input for all our applications, which we're going to discuss. And the green box lists all our applications, and the large green box lists the TC parameters like intensity, wind ready, and 2D winds, which storm classification, which we're getting out of our applications and make them available to forecasters as part of ATCF FDEC. And forecasters can use these objective parameters to gather this raw microwave imagery to get a more full picture of what is happening with tropical cyclone. And next one. So here you can see a larger figure of the channels available on tropics and ATMS. And the difference is, one difference I want to point out is that for ATMS in the top row, the temperature channel is around 57 gigahertz, and for tropics, it is around 115 gigahertz. And that makes difference because for tropics, that temperature channel is higher, which affects how the instrument see the surface, and it also affects how the instrument sees the TC warm core, which is very important for determining intensity. So as I mentioned, we use retrievals, and there are three types of retrievals: statistical retrievals developed by Mitch Goldberg in 2001, no longer operational, but they were operational literally a month ago. And then MIRS retrievals available for all GPSS satellite and for several experimental satellites. And finally, neural network retrievals, which exist for tropics and also being developed for tomorrow IO data. And next. This is just for reference, listing all the steps we have to get to that storm-centric data. You can use that as a reference later. And next. So I'm going to start with our hurricane intensity and structure algorithm, which it uses microwave temperature retrievals to provide global objective dwarf independent estimates of TC intensity in terms of Vmax and minimum sea level pressure and structure. And it also generates 2D winds, and the updated HISA is being transitioned to operations as we speak. And it should be operational hopefully in, I don't know, a couple months from now. Here is the schematics of HISA. In the upper left corner, we start with this vertical temperature profile. This is azimuthally average vertical temperature profile. In this case, the vertical axis is height and the horizontal axis is distance from TC center. And you can see the warm core around, I think, 12 kilometers. And then we perform downward hydrostatic integration to get 3D height and pressure field. And this is the only place where we use GFS model data as boundary condition, and the model has very little effect on performance of HISA estimates. And then we're getting from this gradient wind, and as a final step, we use statistical prediction to get winds and pressure and wind ready. And the reason we want a statistical prediction as a last step is because of the coarse resolution of microwave sounders is just not good enough to resolve the strongest wind, and also because of the attenuation of microwave signal, especially close to the surface in harsh tropical cyclone conditions. And as a separate branch of the same algorithm, we use nonlinear balance equation to get 2D winds. And next slide. Okay, I'm going to show HISA output on using example 2024 Typhoon Con-Gray. Here is the track, and in the middle of this track where it's red, the intensity is approximately 130 knots. And this is not HISA, this is actually a raw brightness temperature from tropics for 91 to 5 gigahertz and for free moisture channels. So you can see very well developed strong storm with a large clear eye. So let's see what HISA gets us. Next. So the upper panel shows intensity. The black is the best track, and the magenta is ATMS, and the cyan is AMSU estimates, which are pretty similar. And HISA captured pretty well the time of intensification and weakening. It slightly overestimated the maximum wind, which we might be able to correct with some bias correction. And the lower rows show wind ready for R34, R50, and R64 knot winds. And again, we can see that HISA captures the difference in size between R34, 50, and 60 knots winds, and also it captures to some extent the storm asymmetry in 4 quadrant. And next. Here we see again this temperature profile which we use as input. Then on the upper right there is gradient wind, and we see deep, well-developed circulation, which what would we expect for such a strong storm. And the row in the lower row we see the temperature 250 hectopascals, which captures really nice, well-developed warm core, and then winds and height at the upper, middle, and lower troposphere, which again very consistent with what we see for that storm. And I'll let Mark. Oh no, sorry. Next one. Okay, so a verification. Here the magenta is the HISA performance, and green is requirement, and we see that for all parameters HISA performance is better than required, so we're doing pretty well here, and this is based on pre-operational data with the new updated algorithm. And next one. Okay, here I just wanted to point out one important place where HISA does not work very well, and that is for small intense tropical cyclones. So you see the con gray, the intensity is pretty reasonable, but for Milton, which was a small intense TC, when it gets strong, HISA really underestimates it, most likely because it's just too small for HISA to resolve, even for statistical algorithm, and that is one of the things we're looking at in Prophet. Okay, Mark.
Okay, yeah. Next slide. Yeah, so everything that Galina just talked about has basically been operational. HISA and its predecessors all the way back to about 2005, starting with the Weather Service. And HISA and its predecessors have been run all the way back to NOAA 15. So now I'm going to talk about some more experimental algorithms that are more on the research side. One of them is, Galina mentioned that we're part of the Tropic Science team. And that was basically a mission with small satellites. They're very small, actually. They're about the size of a loaf of bread, and they weigh about 12 pounds. Is to see, can we do microwave sounding from SmallSats that are kind of built out of really from commercially available parts. And so that mission's been going for a couple of years. They successfully launched 4 satellites and a Pathfinder. And so what we're doing is we're just running the tropics retrievals through the HISA algorithm. So we have the same kind of products, and we're doing a direct comparison with ATMS. And this is just one example. And we are finding that the behavior is somewhat different, given that the channels are a little bit different, but it does show some prospects for being useful for operations in the future. Next slide. And we're also working with the Tomorrow.io. That's a private company that's basically took some of the results from the Tropics mission and building a series of their own satellites. NOAA has permission to get the data from 3 of them. I think they currently have 6 of them up, and we are coordinating with the Tomorrow.io group, NOAA, and also with the SIMS group is involved in that as well. And we are going to try to run the HISA and some of the other algorithms through the sounders from that Tomorrow.io is providing. Next slide. So the next couple of slides are on 3 different experimental applications for intensity forecasting. One is moisture flux, and one is looking at vortex depth. And then Xixing is going to show an experimental algorithm for trying to classify tropical cyclone types, all using the microwave satellite or sounder retrievals. So the first one is looking at moisture flux, and the idea there is that if you take a cylinder that's moving with the vortex that extends through the depth of the troposphere, that's the picture on the left. But basically, if you know the winds on the edge of the cylinder and then the moisture field from the retrievals, you can estimate how much moisture is going into or out of the cylinder. And that's something that forecasters use a lot for trying to explain tropical cyclone intensity changes. typically, if a storm is getting some dry air intrusion, that limits intensification. And then if you're basically in a moist environment where the moisture is converging, that's conducive to strengthening. Next slide. This is just one example. It's a bit of a complicated diagram, but on the top right there is just the intensity diagram for Hurricane Lee from 2023. And the arrow is pointing to the time when we looked at the moisture flux on the edge of the cylinders. And the bottom three diagrams are showing, green shows where moisture is coming into the cylinder at a radius of 100 kilometers, 300, 500. And in the Lee case, there's a lot of green, not much brown. And the point there is that this was a case where there wasn't much dry air intrusion, and that was consistent with the intensification. And what we plan to do is take a large database and see if this relationship holds in a quantitative sense for trying to predict future intensity changes. Next slide. Another thing that we can measure from the retrievals is that we can look at the depth of the vortex. And there's been studies with Doppler radar data from the NOAA P3 aircraft that show that when a storm is starting to rapidly intensify, it tends to build in the vertical. And so we can actually measure the vortex depth just by looking at the level where the cyclonic circulation decreases to about 40% of the value at the low levels. And again, we're collecting a large database of that and relating that to intensity changes. And because HESA also provides a three-dimensional analysis of the horizontal winds, we can measure the vortex tilt directly. And so we're also looking at that parameter from the retrievals, both from the operational GPS satellites and also from Tropics and Tomorrow.io. Next slide. This is some preliminary analysis. There's a lot of points on the plots, but if you concentrate on the lower right, this shows the 24-hour intensity change for a sample of about 300 cases versus the depth of the vortex that we measured from the ATMS retrievals. And in the box there, it's basically showing that the rapid intensification seems to occur in a range of vortex depths. It never happens when the vortex is shallow. And so we think that that's information we could use to provide quantitative information for forecasting future intensity changes. And next slide, I think I'll turn it over to Xixing, and she's going to talk about her classification algorithm.
Okay, I'm gonna introduce one of our applications for storm classification. We call it JACLASS, JPSS for Extratropical Transition Model. JACLASS is a machine learning classification model using GPSS and other LEO satellite data, and we focus on three storm types, which is tropical, subtropical, and extratropical types. In the model, there are three main predictors. They are satellite-derived predictors, ATCF best-track-related predictors, and also the GFS-derived predictor for sea surface temperature. Next slide, please. Yeah, and here we compare JACLASS with the operational model ET class. ET class is NHC operational model for storm classification. And the main differences between ET class and JACLASS is ET class uses IR predictors and the ship's GFS, while JACLASS using the LEO satellite data. Here we use the peer skill score as the main metric to compare ET class and JACLASS, because the PSS can combine both probability of detection and the false alarm rate. And you can see like the ET class, the metrics of ET class, it is in blue, and the JACLASS is in red. And JACLASS works better, especially for the tropical and the extratropical classifications in the comparison. Next slide, please. Yeah, and this page shows our final product of JACLASS. And those are two storm output from the near real-time run in the 2024 seasons. And the output, it is in a time series plot for each data point during the storm life cycle. And the bars here in green, red, and yellow, they are the classified storm types. And also we are showing the lines in the same colors. They are the probabilities for each storm types. And we also, like in the plot, we compare working best track and the jet class in real time. Yeah, and jet class not only provides the classification of the types, but also we can provide the probabilities of different types at different times. It could give us more information and also insights. So like the first figure, it is the Typhoon Conray, and you can see jet class worked very well for this storm, especially for the extratropical transition. And in the second figure, it shows some differences in the subtropical classification for the Hurricane Isaac, especially in the beginning of this storm. There wasn't clear evidence about like on one way or the other, but we believe the extra information from an automated model like this can be helpful in the operational conditions. Now Galina will give us a short conclusion. Next, please. Yeah.
Okay. Yeah, in conclusion, we have updated HISA for ATMS and AMSU for 5 satellites, including SNPP, NOAA 2021, METOP B and C, and these are being transitioned to operations and should be available pretty soon. And we have HISA web page where we will try to put updates. And we also working on experimental HISA for tropics and for tomorrow IO. And we also have several experimental algorithms, including jet class and couple algorithms for forecasting TC intensity. We are setting a new real-time demonstrations for all of these algorithms and plan to have at least some of this output running in hopefully in a couple months, and that would be available to everyone. And we're also starting a new LEO project, which is to develop LEO guidance, which is essentially artificial intelligence version of HISA, where we'll try to forecast the same parameters, but use more heavily machine learning. And next slide. I mentioned a few times that we are about to launch a new web page. So here is a snapshot. We're still working on this internally, but basically this would be focused on GPSS, tropics, and maybe some tomorrow IO data. Tomorrow IO is more complicated because they have limitations of what could be displayed. Yeah, so basically we're going to provide some basic storm information and also all available output from HISA, predictors from jet class, moisture flux, and all experimental stuff with vortex depth and possibly additional data as well. That's all we have. Thanks.
All right. Well, thank you guys for your presentation. And now, before we turn to audience questions and the Q&A, we're going to have some quick reminders for folks that are online. First thing here, as you see on the screen, to view our interactions here within the Q&A, please, you can change your layout within the Google Meet interface here from tile to hide tiles without video. And in addition to that, what we are looking forward to in the next 2 weeks, since next week will be, there'll be no presentations next week just because of the holiday and 4th of July. But in 2 weeks, we'll be looking forward to Kevin Teal, who will be presenting on the Tales from the Test Bed, the 2025 Satellite Proving Ground Hazardous Weather Test Bed, or HWT. And that'll be on Thursday, July 10th at 12 p.m. Eastern. So we'll look forward to that. In addition, if you have any questions about SBC or any kind of satellite products, you can contact Sheila Kopai from the TowerS team. And but for now, we will now transition to audience Q&A. And just as a reminder, folks, you can type in your questions within the chat interface there as you whenever you can. But I'll start out with a few questions that I have of my own. And so for the CIRA team here, my first question is, with respect to the tropics microwave sounder data and also Tomorrow I/O, can forecasters or users that are on this call, can they access, is there any near real-time web pages, whether it be trying to access data files or near real-time imagery available for users to access?
For tropics, yes, there are some real-time pages. I don't have a list, unfortunately, right now, but yes, tropics science team is making some real-time data available, and we also will be doing that, making that available at CIRA, and some of it is available at SIMS. And the same is true for Tomorrow I/O. Tomorrow I/O is more complicated because there are some, it's a commercial project, so there is restrictions of what could be shown, but I believe we can pretty much unrestricted share the data with National Weather Service. So while it might not be available for general public, we will try to this data should be available to forecasters. Yes.
Okay. Good to know. I appreciate that. My next question I have for the team here, within the series of products that you guys have displayed here and mentioned through this presentation, is there any plans to incorporate the quick sounder data once that satellite launches within the next year or two, tentatively, and then be incorporated into your products?
I'm actually not sure what you're referring by quick sounder.
Within the next year or two, as of right now, you know, with the next generation of satellites for JPSS, it's NEON.
Oh, okay.
And their first project is Quick Sounder, which is another microwave sounder, which assuming it launches, I think it's supposed to be planned for next year, 2026.
Yeah.
Would that data be integrated into your guys' projects?
Yeah, we definitely can look at that and would be interested to look at that, and it all depends of funding availability.
Okay, fair enough. And I do see that there's some questions in the chat, so I'll start with Matt Gunshore. He asks, how are you guys feeling about the effects on TC forecasting accuracy with DMSP shutting down this month, EOS satellites in September, and SNPP probably sometime within the next year?
Well, I'll take that one if it's okay with you, Galina. I feel like the particularly the microwave imagery that comes from those satellites, I mean, it's an important tool for forecasters. You know, looking at the structure, you can look at concentric eye wall formation related to intensity change. You can look at rain band formation. So, I mean, it is a loss. I mean, not having less of those available is going to be, you know, there's going to be some degradation for that. And then fortunately, not all of the microwave sounders are gone, so there will have some to use, but yeah, that will be a bit of a loss.
All right. Another question has come into the chat from Michael Jemkowski. He asks, how important are the Defense Meteorological Satellite Program, or DMSP, early morning orbit SSMIS data to TC analysis and forecasting? Are you concerned those data will be going away in the near future with no replacement planned? Kind of essentially follow on from the first question, if you had anything else to add.
Yeah, I think from the point of view of data assimilation, because we do have other satellites with sounders in the similar orbits, you know, for the ATMS, I think there'll be less of an impact there. More is always better, but I think in terms of the data assimilation, having you know, actually more modern microwave sounders, but the imagery is going to be a loss. I mentioned before, is having those other looks and the higher resolution that you can get from some of the DMSP. So I think it's more on the imager side is going to be the loss, and maybe less so on the sounder side.
All right.
Yeah.
Oh, go ahead, Galina.
And also, METOP B satellites are on the morning orbit. I'm not totally sure if it's how different it is from DMSP, because I think all GPSS satellites tend to be in the afternoon, which is kind of unfortunate for tropical cyclones. And as Mark said, this SSMIS, I think that is one of the highest resolution imagery available, microwave imagery available. And I think AMSR provides some similar resolution, and maybe GPM, GMI. But yes, it's definitely it definitely would be nice to have more of this, because all the sounders have much more coarse resolution. And I also think I'm actually not sure which of these have 37 gigahertz, but I think that is there isn't very many satellites left which have 37 gigahertz data.
All right, thank you, Galina. I do see in the chat, I believe from Iuli, she does mention that as a FYI, that the HISA is now running in operations at NESDIS OSPO and AWS Cloud, or the Amazon Web Services, and there's a link there that she provided there for the OSPO HISA product page. And then I believe Michael did follow up there. He also mentions that FYI, the 22nd Annual Symposium for Operational Environmental Satellite Systems at the January 2026 AMS Annual Meeting, which will be in Houston, is promoting a panel on this. Or there'll be a panel on that for AMS. And as we transition to another, planning. That's what planning. Another question for the CIRA team here is, for the storm type classification method, JET class, what advantage is there to using microwave retrievals as inputs compared to just using global model analysis fields?
I think if we're using the satellite input, it is kind of the observation, like true data, but for the analysis, global analysis, they are still kind of the numeric model, so it's kind of, we can take advantage of the observation data.
All right, thank you. Oh, here's another question in the chat here from Douglas Schumacher. He mentions, what are the latency expectations from satellite observations to TC products? Has the use of direct broadcast data for METOP JPSS as input ever been considered as a way to get this data faster over certain regions?
I would say the latency, it really depends on when, on the receiving stations and when we get the data. And I might be wrong with that, but I think it's there are twice as many stations available for NOAA 20 and 21. So I think it's about 1 hour, and maybe 45 minutes to 1 hour, and it's up to 2 hours on GPSS on SNPP. In terms of direct broadcast, I should admit I've been trying to do something with direct broadcast, and I was never able to get direct broadcast data. So it's a big mystery to me how people ever get this data. If we get input from direct broadcast, we would be interested to try to run it. So if someone can provide me a link to where we can get this data, we would be interested to look at it.
All right, good to know.
Yeah, we did make a little progress with that when I was still at the Hurricane Center with the direct broadcast. There was a couple sites, the Puerto Rico one, there were a couple of key ones that we were working on trying to get the data. So I think at least at that time it was available. Galina, we'd have to coordinate if we wanted to use it for our experimental stuff.
All right. Additionally, Scott Lindstrom from Sims has another question there. It says, does HISA have a dependable signal for all storm strengths? Maybe there's too much variability among storms to make a general statement. Any response there?
I can start with that. I think we feel like the with really weak storms, the warm core signal is barely above the noise level, so weak storms are difficult. And as Galina showed, really intense little storms are difficult. So it's kind of from about tropical storm strength to major hurricanes as long as they're big. So I think it's kind of in the middle where it works the best.
Additionally, Li Hang Zhao says, thanks, Mark. Is NHC planning to use DB data for AMSR3 and METOP SG?
Yeah, that one I have to coordinate with them. I do have a meeting with them in 20 minutes, so I can I can try to get an answer to that question.
Sounds good. Another additional question here. One of the main limitations of microwave sounders for tropical cyclone analysis is the horizontal resolution. Do you have ideas for how you could bring in supplemental data to improve the intensity and wind radii estimates, Lisa?
Yes, we were thinking that it would be good to add use as input to HISA some information about storm size. And one possibility would be to use infrared data, possibly from geostationary satellites, and storm size estimate from this data as additional HISA predictor.
All right. I also see that Sheldon Cusselson also here from CIRA, he does mention that you should contact Wanmeng as their CONUS snowball rate product uses direct broadcast, and he does refer you guys to a link there. And then additionally, I see Douglas Schumacher mentions SSCC SIMS operates a number of direct broadcast sites. He works on those projects, and you can reach out to him there directly via that email he provided in the chat. And then with that, I know we're coming up to almost 15 before the hour here. So I'll ask one more question here that I have for you guys. With all the products that you mentioned today, do you guys have any satellite quick guides that are developed for these, whether it be operational or experimental products? And if so, where can they be accessed?
No, we don't currently have any quick guides, and I actually think we started coordinating and developing quick guide for HISA, but that kind of never was finalized. So that's a good question, and we probably should go back to it, and maybe I will coordinate with you on that.
Okay.
Because I know you're working on this quick guide, so thanks for mentioning.
From training and stuff, it seems like there's more opportunities to develop these training materials that can help our forecasters.
Right.
But with that, I'm not seeing any other questions in the chat, so I'll come to a close now. And we once again thank our presenters, and I'll transition back to Brian for any kind of closing remarks.
All right, thank you, Jarell, for moderating today's session, and of course, we thank our three speakers, Mark, Galina, and Zhixing, for an informative talk. Triggered a lot of questions and interesting discussions. So obviously, there's a lot of interest. Hey, as Jarell told us earlier, please come back 2 weeks from now. No SBC next week, but 2 weeks from now, please join us when Kevin Thiel will be presenting Tales from the Testbed, the 2025 Satellite Proving Ground Hazardous Weather Testbed Takeaways. So we look forward to seeing you there in 2 weeks. We thank you all for your participation, and we'll wrap up the call today's seminar right here. Thank you.
Thanks.